Okay guys, here's another example here on Euclidean geometry. Now let's have a look at this question. It's probably from a past paper. Okay, so it says here in the diagram O, you will remember guys from the lesson I said that immediately when a question will tell you what type of angles you need to be aware of in a given question. If you even watch that lesson video, please make sure that you watch it. It's video linked to this video. Open the playlist and then go to that video and then just have a look. I did try to summarize it way forward, because I know mostly when you guys watch this, it's when you are busy practicing or we are busy preparing for a test or for an exam. So to make life easy for you, I have already done most of the work for you. Just go see that video and then come, let's continue on this one. I've got two questions here. Here's the first question here, and here is question number 2 here. Right, so please stick around on this video until the end. We will do it together here, right here at Maths with Gaston. My name is Gaston Mapala. Welcome again. So let's go through this question. In the diagram, O is the center. So I've already told you guys, immediately when they speak of the center, start thinking of angle at the center is twice angle at the circumference. So angle at center, so you must start thinking of this angle at center equals to twice angle at the circumference. Okay, so think of this angle because they spoke about the center. Keyword here is what? Center. And they spoke of the radii, which is this one and this one. It means what? Is suspend equal sizes. So if this is a radius here, which is OH, and then therefore even here, it means therefore this angle here and this angle here, they are therefore equal. Okay, so now they speak of the tangent. It means now you've got a tangent here. If a line, then this one is going to be what? Tanchord theorem. So this angle here will be equals to the whole of J. So the whole of J, let me just do this quickly. The whole of J will be equal to H1. Okay, just to make life easy for yourself, the whole of J will be equals to H1. I hope you guys are following. The whole of J will be equals to H1. And then they said a tangent is drawn from K to touch the center of the circle at H. So because they said that's a tangent, and then they say triangle, let's see, triangle H. So this is our triangle here, triangle H. I'm just gonna circle them G and therefore J are drawn such that, so we've got parallel lines here, as you can see. JD, they are parallel. So it means now if they speak of these parallel lines, we must start thinking of fan. Okay, must start thinking of fan, corresponding, conterior, and alternating angles. All right, great stuff. So I think we've got what it is. O is going to be equals to 2x. So therefore, if you start here at the center, you can see O is going to be twice angle at the circumference. Angle at the center is twice. So therefore, it means here it's gonna be x, right? And therefore, if this is x, and then I've got these two lines that are parallel, therefore it means even here is going to be x as well. Alternating angles, and then what else is also equals to x? Because let's check. Let's see. Let's have a look here. Just want to see what else. Okay, it means also the whole of this. Yeah, so it means the whole of J is equals to also equal to x as well, due to Tanchord theorem. So let's go ahead and have a look at our question here. Let's look at question number 8.1.1. It says name and give reasons 3 angles each equal to x. Right, so it means now this is 8.1.1. this is the one we just did now, guys. So we said it means G is equal to angle at the center is twice angle at the circumference. G is equal to O. Okay, so it's equals to what? O1. Yes, it's equals to O1. And then our reason here will have to be angle at the center, angle at center it's equals to twice angle at circumference. So therefore we already know what is oh, excuse me, sorry, you go back, you already know what is the angle here. Here is equals to 2x, therefore here is equals to 2g. So we're looking for g, we're going to divide by 2 both sides, therefore g is going to be equals to x. Great stuff. That's just the first one. Okay, let's go to the second one. The second one here, we're going to say h1 is equals to g. Okay, and then our reason here will have to be alternating angles. And then why are they alternating? Because we have to tell them why, né? Because we have got these two lines that are parallel. There you go. So because these two lines are parallel, therefore this one forms a Z. So I hope you guys can see the Z there. There it is. Yeah, so these two angles therefore here, they will have to be equal. Okay, and then what else again? If we have a look at the set, this is a tangent, therefore you already know that the whole of J, like I stated here, is going to be equal to that. So we're going to say H1 is going to be equals to the whole of J. Reason being a Tanchord theorem, because what the question, the statement on the question spoke of the tangent. All right, great stuff. Right, okay, now let's move on to question 8.1.2. let me change the color here because we're going to need it. 8.1.2 said prove that h2 is equals to h3. So now let's have a look. H2 is this one here, is equals to h3. So 8.1.2. so what I will do now, I'm just going to erase anything that has to do with the red color, only just a minimal. So now let's come here and have a look. So guys, if you look at this one here, we say we have got this theorem here that says if you've got a circle and then a line is drawn from the center of the circle to the chord, it will bisect the chord and making it perpendicular. So now what do you have here? You have got this one here, which means that h1 plus h2 is equal to 90 degrees. Okay, reason being, the reason is you have got what, radius, okay, or radii. They normally say radii is what, perpendicular to the tangent. So it's perpendicular to the tangent. Okay, so now we already know what is h1. H1 is going to be what, x. So therefore it means h2 will be equals to 90. So therefore h2 is equals to 90 minus x. All right, so now it means now we need to go on and prove that h3 is 90 minus. Let's have a look at h3. H3 is here. So if h3 is there, we have got this triangle. So I'm just gonna come and edit here. We're gonna say in, because guys, we've got this triangle here, as you can see, OJ. Okay, so in triangle OJH. So I'm just gonna put it here for the sake of understanding, guys. If you have a look at this triangle here, that is here, you've got a radii there, radii there. Here you have got 2x. Then this is O, and then you have got J here, which is J1, and then you have got here also H3. Okay, so H3 here. So what you would do in this case, you're gonna come here and say, okay, no, sum of angles in a triangle, they are equals to 180. So this is what you would do in this case. You're gonna come and say, okay, J1 plus O1 plus H3 is equals to 180. Okay, we already know what is O1. So O1, okay, do we know what is J1? Okay, we really don't know what is J. Okay, but remember J1 and H3 is equals to wait a minute. Okay, so let's see. Let me substitute first J1. Okay, not the whole of J1 is equal to, here we are going to have what, 2x plus H3, which is equals to 180. So therefore J oh yes, remember now here in this case, as you can see, J1, okay, this is our equation here. Okay, if you have a look at here, J and they're equal, because now let's say H3 plus H3 is equals to J1, our reason being radii. Okay, or you can say angles, opposite equal sides. Okay, so therefore it means now I can just put H3 where there's J1, I can put H3, so it's going to be H3 plus another H3, then I take minus 2 to the other side, is going to be 180 minus 2x. So therefore guys, I'm just gonna continue here with this one. So you're gonna have what, 2H3, and then therefore we're gonna have 180 minus 2. Then what do you do now? You divide everything by 2, both sides. Divide everything by 2, then you're going to have H3 is equal to 90 minus x. Okay, so therefore this simply means I'll continue here guys, I don't have space anymore, or I can continue up there, it's fine. So this simply means this H here, it's equals to that one, because H3 and H2 is equals to 90 minus x. So therefore this gives us a situation where H2 is equals to H3. Are we still together guys? I hope we're still together. If we're still together, like this video so that YouTube can recommend it to many other learners as well. If you guys understand me, let me know. If I'm too fast, let me know. If I'm a little bit too slow, please let me know as well. And if you don't understand, don't hesitate to drop a comment and then let me know what you guys think and ask a question thereof. Okay, let's move on to the next question here. Okay, here's a question here. It says in the diagram below we have got what, a cyclic quad. Okay, hope you guys can remember when I say cyclic, the word here cyclic quad means what you're gonna think. You must start thinking of external angle of a cyclic quad, and then you must also start thinking of what opposite angles of a cyclic quad. They're also equal to 180. Now they give us an angle there. They said this angle K with K angle L is equals to 85. We see that here is 85 is given, and then we have got diagonals. If they speak of diagonals, you guys must start thinking of angle on a straight line, things like that. Okay, let's see how the diagonals are looking. Okay, they're looking like that, and then we say P is a point. It's a point on the circle, and then MP is produced to T. Okay, a point outside the circle. Where is a T here outside the circle? We see we've got a chord. LP is drawn. Where's LP? LP is there, is drawn. Then they give us angle M, and they also give us angle N1. Okay, great stuff. So now they are saying here 8.2.1. they said name and giving a reason another angle that is equal to Y. Okay, great stuff. So how many angles are equal to Y? Okay, let's have a look here. Oh, they just said another angle, so maybe it's one angle the way I see it. This question was with only 2 marks guys. We got 2 marks there, and then here it was with the first one, it was with 3 marks here, and then also 2 marks here. So nothing hectic really. So now let's have a look which angle is equals to y. Okay, if we have a look here, if they say this is a cyclic quad, we have got a chord there, it has got an angle here. Okay, and then it is also equal to this angle here, angle suspended by the same segment. Remember this drawing, guys, from our lesson. We have got an angle. If you have got that, then you have got a chord here, and these angles that are equal, so which is exactly what I'm seeing here. So it means therefore we have got M, which is equal to N2, okay, which is also where M is equals to Y, and this is equals to N2. But however, you must give a reason here. You've got angles in same segment, right? Angles in same segment, right? Great. Now 8.2.2, which is what? Which is 8.2a. Okay, now let's have a look at A. They're saying calculate and give reason the size of Y. So they want us to calculate the size of Y. Okay, now let's have a look. So it says here the size of Y. All right, let's do this. Okay, so we know, because they speak of cyclic quad, remember what I said earlier. I said if they speak of cyclic, was thinking of the exterior angle of a cyclic quad, we're thinking opposite angles of a cyclic quad. So this angle here, okay, maybe I should use a different color for the sake of understanding, guys. All right, so this angle here, guys, this angle here, it is equal, the sum of these two angles gives us 180, because what they already said that this is a cyclic quad. So this is what you can do. You can say L plus N, the whole of N, must give us equal to 180, and our reason in this case would have to be opposite angles of cyclic quad, of a cyclic quad. Okay, great. So now we have got what? 87. Okay, and then N here we know that N is made up of these angles here. Okay, which is Y. It's made up of what? It's made up of 2Y, and we've already proven here that N2, it's also, there's another Y there as well, which is equal to 180. Okay, interesting question here. Okay, y and y will give us 3y, and therefore 180 minus 87. This one, 180 minus 87 is 3y, is going to give us what? Is going to give us 93. So therefore divide everything by y. Y is therefore going to be equal to, remember y is an angle, yes, it's an angle, so y is going to give us what? 31 degrees. Great stuff. So let's not forget here, y is an angle. It's not just a variable. So this would be how you would calculate y. So they further say, now B, they want us to calculate T angle P. Okay, now let's go ahead and look at this in our diagram. Where is T? T is here, and then where is P? P is here, and then they want us L. So L is here. So they want us to calculate this angle here. Okay, quite interesting indeed. Okay, now let's have a look at this one here. Which one is a cyclic quad? First, let's see. They said cyclic quad is K. Here's K here. K, I'm gonna just circle it as well. K, L, M, N. Okay, N. So this is what a cyclic quad. Okay, let me have a look. Okay, they didn't say anything about parallel lines, so we don't have parallel lines here. So let's have a look. Is that cyclic quad? Let's have a look. I said it's equals to what? let's have a look. So if I were to put y here, this will be times 2 of that, so this y, this here, n1 will be 62, if I'm not, after we just calculated y there, so it will be equals to 62. So now if I'm looking at this properly, okay, so cyclic simply means drawing something around that circle. So now if I have a look at this one, I also got this angle here as well from this cyclic quad, so this angle here. Okay, but this looks like, if I were to look at this, if we say, looking at this properly, if we were to say, I think, guys, let me know what you think on the comment section below. I think this angle here, this one, the one that they are referring to, the one of P, it is equal to this angle here. Looking at this here, I'm just gonna draw it properly up to there, then you go all the way here, but you cut it here, then you go all the way there, you see. So now this gives you a cyclic quad of PMLN. I don't know because, but they didn't say that this is cyclic, but it has got a circle around it, so I'm just going to cheat it and say exterior angle of a cyclic quad, which is P, is equals to N2, reason being exterior angle of a cyclic quad. Okay, so I'm just going to cheat it, guys. I know there's many ways to kill a cat. If you've got another way of finding this, or the other way that you have managed to solve this one, please let me know, guys. I'm just cheating it because I can see that is already 2 marks, so therefore it means P will therefore have to be, we already found y, you have to be twice as y, which is 31 degrees there, which will give us 62. Okay, and that's how you would deal with this one. I know, guys, I know what you guys thinking. Please make sure that you understand. If you don't understand, let me know in the comment section below. Like I said, the question will tell you which angles to focus on. You see here, there's no parallel lines because the question never said anything about parallel lines. They only talk about the cyclic quad. And if you ever look at here, the only thing that we use was cyclic quad and then angles on the same segment. Angles on the same segment will be there if you've got a cyclic quad. So, guys, I mean, really, I mean, this is... it doesn't get as simply explained like this one. I am Gaston Mapala. Let me see you on the next video where we'll be doing more of Euclidean geometry.